Hello everyone, welcome back to the channel. In this video lecture, we will solve this problem minimum add to make parenthesis valid. This is a Leetcode medium problem. In this problem, first we define a parenthesis string. So a parenthesis string is a string which consists of opening and closing parenthesis only. And a valid parenthesis string is and a parenthesis string is valid if and only if it is the empty string. That means it does not contain any character, or it can be written as A concatenated with B, where A and B are valid strings. So A, B will also be a valid parenthesis string. Or it can be written as opening parenthesis A closing parenthesis, where A must be a valid parenthesis string. In this problem, we're given a parenthesis string S, and in one move we can insert a parenthesis at any position of the string. It can be an opening parenthesis or a closing parenthesis, and we have to return the minimum number of moves which are required to make the string S a valid parenthesis string. Fine. Let's see the input and output form. In the input, we'll be given a string S consisting of opening and closing parenthesis, and in the output we have to return an integer representing the minimum number of moves required to make the string S valid. Let's see the constraints of the problem. The length of the string S may go up to 1000. That means the largest string that we can have can be of length 1000, and any character in the string is either a closing parenthesis or an opening parenthesis. So let's better understand the problem statement using an example. So we have three cases. If we have an empty string, it is a valid parenthesis string, or we have a valid parenthesis string A and a valid parenthesis string B, then A, B will also be a valid parenthesis string. Let's take an example for this case. For instance, A is this while B is this. They are valid. So A is a valid parenthesis string, B is also a valid parenthesis string. Then the string generated by concatenating these two strings is also a valid parenthesis string. Then any valid parenthesis string, let's take this one, can be written inside an opening and closing parenthesis. So this will also be a valid string. So these are the cases that we have to take care of while checking for a valid parenthesis string. So let's take this example, and we want to count the number of moves that we have to make so that this string becomes a valid parenthesis string. So you can see that all we have to do in this string is to insert an opening parenthesis at the starting position to make it a valid parenthesis string, because this string is not a valid parenthesis string as it does not satisfy these properties. Hence, we have to insert an opening parenthesis here to make it a valid parenthesis string. So the answer for this test case is 1, because here you can see that for each opening parenthesis we have an accompanying closing parenthesis, and hence it makes this string a valid parenthesis string. Let's see how we can solve this problem. So let's see the intuition to solve this problem. So all we have to do in this problem is to start traversing the string S from the first character, and we need to check if the substring or prefix that we encounter is valid or not. That means the prefix that we encounter, if all the prefixes of this string are balanced, then and the number of opening brackets and closing brackets are equal in the entire string, then that string is a valid parenthesis string. So to solve this problem, so we have to balance the opening parenthesis with the closing parenthesis, and every prefix of this string must be balanced. So let's take a variable, let's call it balance. BAL stands for balance, initialize to 0, and we start traversing the string from the first character. We see a opening parenthesis, and since we encounter an opening parenthesis, balance becomes 1. Because what is the definition of balance? The definition of balance is that the number of opening brackets minus the number of closing brackets. So here we encounter an opening bracket, so balance becomes 1. Then for the next character we encounter a closing bracket, and therefore the balance becomes 0, because in this prefix the number of opening parenthesis minus the number of closing parenthesis is 0. Fine. Then we move to the next character, the third character, and in this prefix we have an extra closing bracket, so the balance becomes -1. So in the prefix of length 3 the balance is negative. That means we have an extra closing parenthesis, and hence we have to add an opening bracket to balance it, to manage this closing parenthesis. And hence let's take another variable answer, which is used to count the number of opening brackets that we require to keep this balance non-negative for every prefix. So answer becomes 1. That means in the prefix of length 3 we have to add one opening bracket to make the balance variable for this prefix non-negative. Then we move to the prefix of length 4 and we encounter, and after we add one opening parenthesis, the balance again goes 0, because we have added a closing and opening parenthesis here. Then we move to the prefix of length 4, where again at fourth position I encounter a closing parenthesis, which makes the balance variable again -1, because balance variable is basically the number of opening parenthesis minus the number of closing parenthesis. And since it becomes -1, that means we have to add an extra opening parenthesis to make it balanced, to make the prefix of length 4 balanced, and hence the answer becomes 2. That means we have added 2 parentheses here. Then we move to the prefix of length 5, or the fifth character, so namely the entire string, and here we again encounter a closing parenthesis which makes our balance variable again -1. That means in the prefix of length 5 we have an extra closing bracket, and since this is the case we need an extra opening bracket to keep this prefix balanced, and hence the answer becomes 3, while the balance again goes to 0. And in this way we traverse the entire string, and finally we have answer as 3. That means we need to add 3 opening brackets in the given string S, and the balance is 0. That means we do not have any extra closing bracket, therefore the answer is 3 plus 0, that is 3. What if this balance variable is positive? So there can be a case where we have this balance variable as positive, because this variable simply counts the number of opening braces. So let's take the case of this type of string. So in this type of string all we have is 3 opening braces, and if we start traversing the string from the first character, initially we have balance as 0. Then after I encounter my first character, which is an opening bracket, balance becomes 1. That means I require 1 closing braces to make this string balanced. Then I go to the next character, it is again an opening braces and the balance becomes 2. Then I go to third character, it is again an opening braces and the balance becomes 3. And finally I have 3 as the answer, which simply represents the number of closing braces that I require to make this string balanced. And this is the case indeed. I require three closing braces here to make this string a balanced string, or a valid parenthesis string, and hence the answer is 3. So this is how we proceed in this problem. Fine. Let's see the implementation for this solution. So before that we have to emphasize on 2 important points. The first is, what is balance? Balance is defined as the number of opening brackets minus the number of closing brackets at any position of the string. So at any ith position or a prefix of length I, all we have to do is to count the number of opening brackets and subtract the number of closing brackets. That will give me the balance, or the resultant number of that will give me the balance for that prefix, and this balance must always be positive. That means the balance must always be non-negative. It can be 0 or positive at any position of the string or for any prefix of the given string, and that's the target. The balance is 0 plus every prefix has non-negative balance. Let's see the implementation for this solution. So this is the min add to make valid function, which takes in the given string s. It calculates the length of the string, initialize answer variable with 0 and the balance with 0. Then I iterate over the given string s, and here I am checking if I encounter an opening bracket, then the balance is incremented, otherwise the balance is decremented. So if I encounter an opening bracket, the balance goes up by 1, otherwise if I encounter a closing bracket, the balance goes down by 1. And if the balance goes negative, that simply means I have extra closing bracket, and since I have extra closing bracket, I have to add extra opening bracket to make it balanced. That's why I'm incrementing the answer variable by 1, and this will simply make our balance variable 0 because I am balancing this extra closing bracket. Fine, so this will again turn to 0. So this is how I'm proceeding for each prefix. I'm simply making sure that the balance here stays non-negative. If it goes negative, I'm always there to add a opening parenthesis here. Now finally, answer, which represents the number of opening parenthesis, plus balance, which represents the number of closing parenthesis which I require, will simply give me the answer for this problem or for this string. That is the total number of parentheses, whether be it open or closed, which are required to make the string s as a valid string. Fine. So that's how this function is working. Let's move to the implementation part. So let's create this function min add to make valid, which takes in the string s and returns an integer representing the minimum moves to convert the string s into a valid. We calculate the length of the string and declare two variables answer and balance representing the number of opening and closing parentheses that we require to make the string s as a valid string. Then I'm iterating over the string s, and here I'm checking if we encounter opening bracket, then I'm incrementing my balance by 1. That means I require a closing bracket for the corresponding opening bracket. Otherwise, I am decrementing the balance by 1. And if the balance goes negative, then I'm always there to add the opening parenthesis here, which is represented by the answer variable, which turns the balance variable again to 0 to make the prefix up to I balanced. Finally, the answer would be the number of opening parentheses and closing parentheses that I require to make the string s as a valid string. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java, and this is the implementation in Python. So that's all for this video. If you like the video, then do like it and make sure to spread the word and subscribe to my YouTube channel. I will see you in the next video. Till then, take care. Bye bye.